Welcome guys to this amazing channel of Mathematics JEE. Today we are going to discuss some JEE main level problems on integral calculus. A total of 10 questions are to be discussed in this video. I have shared the question PDF in the description. You can check it out and comment your score in the comment section. So this is the first question that we are going to discuss. The question says, let box x denote the greatest integer less than or equal to x. Then the value of pi square times some integral is equal to 4 options are given to us. So as you can see, this question was asked in JEE Main 2021. And it is a question of definite integration. So I have named this integral given in the question as pi square times I, where I is this integration. Now we have to focus on this function. Now we know the properties of greatest integer function. It is discontinuous at every integer. So when x varies from 0 to 2, there is only one integer, which is 1. So we have to break this function at x equal to 1. So there will be two different functions when x varies from 0 to 2. When x varies from 0 to 1, the greatest integer x will become 0. So this part will become x minus 0 whole to the power 0, that is 1, times sine pi x by 2. So it simply becomes sine of pi x by 2. Now coming to the second part, here if x varies from 1 to 2, greatest integer x will be 1. So this part will be x minus 1 whole to the power 1. So this will be x minus 1 times sine of pi x by 2. Now the given integral I, which is sine of pi x by 2 into x minus greatest integer x whole to the power greatest integer x dx, can be written as the sum of two separate integrals, which is integral 0 to 1, and from 0 to 1 our function is this. Into dx. Similarly, from 1 to 2 our function is this. Okay. Now we have to calculate these two integrals. Now this part is quite simple. As you can see, this will be minus 2 over pi cos of pi x by 2 with limits 0 and 1. So this part is evaluated, and then this part we can again write as x sine of pi x by 2 dx and minus integral 1 to 2 sine of pi x by 2 times dx. Now this part is also quite simple. It will be simply what? So there is a minus sign outside, so the minus and the minus from integration will cancel each other. So it will be plus 2 over pi cos of pi x by 2 with limits 1 to 2. Now coming to this part, This is a definite integration that has to be solved by integration by parts. So by the rule of integration by parts, we know that if we are given two functions u into v and we are to integrate those two, the product of those two functions, then we have to apply this formula. So u times integral v dx minus whole integral of du dx into integral of v dx and dx. So this is the concept here, integration by parts. Now coming to this particular integral, so it will be x times sine pi by 2 x into dx. Now we have to apply the rule, so it will be, so basically here u is the first function and v is the second function that we have to choose, such that the first function we choose, the differentiation of this that function will be easier, and the second function that will be choose, the integration of that second function must be easier. So here we have to choose x as first function and sine pi x by 2 as second function. So this integration will be x times minus 2 over pi cos of pi x by 2, and as this is a definite integration, we have to put the limits from 1 to 2 in both, in all together in this part, minus, and now we have to write this part. So this is integration 1 to 2. Now the derivative of the first function is 1 and the integration of the second function is minus 2 over pi cos of pi x by 2. So minus and minus will become plus, and then 2 over pi cos of pi x by 2 into dx. So here we have to evaluate this all together. So the first part is giving us minus 2 by pi into, if we put x equal to 2, so this becomes 2 into cos pi, that is minus 2, and if we put x equal to 1, then see here cos of pi x by 2 will become 0, so the whole part will become 0. So this, now 2 over pi and integration of cos of pi x by 2 from 1 to 2, so this will be simply 2 over pi again, and then sine of pi x by 2 with limits from 1 to 2. Now this will give us 4 over pi plus 4 over pi square, 4 over pi square into, inside the bracket it will give us sine of pi. If we put x equal to 2, then sine of pi means 0 minus sine of pi by 2, that is minus 1. So it will give us 4 over pi minus 4 over pi square. So this is this integral. Now if we calculate our previous integrals, then let us calculate them. So this will become minus 2 over pi cos of pi by 2 minus cos of 0, that is minus 1, so 2 over pi, and similarly here 2 over pi outside and cos of pi minus cos of pi by 2, so it is minus 2 over pi. So if we are to add those all those expressions, then we get our I will be something like this: 2 over pi, then plus, then 4 over pi minus 4 over pi square minus 2 over pi. So this will become, this will cancel each other, and 4 pi minus 4 over pi square. So pi square times I will become 4 into pi minus 1. This will be our answer. So this is the second question that we are going to discuss. So in the question we are given that in is equal to this integral. Then we are asked the value of summation n equal to 1 to 10 I of 2n plus 1. So this will be what? If we put n equal to 1, then it becomes I3 plus simultaneously if we put n equal to 1, 2, 3, 4, 5, 6 up to 10, then we will get I3 plus I5 plus I7 plus so on up to, if we put n equal to 10, then it will become I21. So we are basically asked to find this value. Now as we can see, this particular format of in is very much favorite in the perspective of JEE. They love these expressions because as you can see here, the limit is from minus a to a, where a is pi. We know that there is a property in definite integration that is called King's rule. So it says a to b integral fx dx is same as f of a plus b minus x dx, and this integral from a to b. So this formula or this property of definite integration will be used in this question because we have exponential term involved here, and also we can notice if we sum up the limits a plus b, it becomes 0, and then a plus b minus x becomes simply minus x. So if we put minus x instead of x here, so this part and this part both will alter their sign, but as they are dividing each other, then the net effect will be cancelled. So sine of nx by sine x will remain same, and only this x here, this x will get changed to minus x. So applying this, we get in equal to integration minus pi to pi, then sine nx by sine x as it is, then 1 plus pi to the power minus x into dx. Now this we can simplify as sine of nx by sine x into 1 plus pi to the power x, and also the pi to the power x in the numerator. So this part we can simplify as this. Now as we have got two expressions for in, we can simply add them, so that we are noticing that 1 plus pi to the power x term will get cancelled upon adding these two integrals. So let us add them. 2 times in will become what? Minus pi to pi integral sine of nx by sine x into 1 plus pi to the power x, and again 1 plus pi to the power x in the numerator. So this will cancel each other, and we are simply left with minus pi to pi integral sine of nx by sine x dx, this part. Now 2 times in is simply 0 to pi integral sine of nx by sine x dx, and 2 times of this integral, because we know that minus a to a f of x dx equal to 2 times 0 to a integral f of x dx if f is even. So if f is even, then this property holds. So this function is definitely even, because if we put minus x instead of x, the net effect in this function will be 0. So there will be no change in this. So this will be f of, so this part we write, because f of x is same as f of minus x. So I of n will become 0 to pi integral sine of nx upon sine of x into dx. This is our derived expression of In. Now see, in the question we are asked to find the summation of I3, I5, I7 and so on. See, if we try to put different values of n here and try to integrate all those expressions, this will be really time consuming, and maybe perhaps we will not be able to solve that in our given time. So we have to find relation between in plus 1 or in plus 2. Basically we have to play with the in plus 1, in plus 2 and try to find a relation that relates them. Now let's try in plus 2 minus in. The idea that strikes my mind here is that if we see the expression under the integral sign, the denominator is same, but the numerator contains the term of n. So if we put here simultaneously n plus 2 and n, then what this becomes? So this becomes sine of n plus 2 x upon sine x integration dx minus again integral sine of nx by sine x dx. So this becomes, we can take the denominator common and then sine of n plus 2x minus sine x dx. Now if we apply here sine c minus sine d, that we know is equal to 2 times cos of c plus d by 2 into sine of c minus d by 2. So it becomes 2 times integration cos of c plus d by 2, n plus 2 plus n, sorry, this will be n. So cos of n plus 2 plus n means cos of 2n plus 2, that is cos of 2 into n plus 1, divided by 2, that is cos of n plus 1. So cos of n plus 1 x into sine of n plus 2 minus n divided by 2, that is 1, that is x, sine of x upon sine x dx. Now this will cancel each other. So we are basically left with the integral of cos of n plus 1 x dx from 0 to pi. Now this is quite simple, 2 over n plus 1, and the integration will give us limits from 0 to pi, and this becomes, so we know that inside the sine function, if we put anything equal to some integral multiple of pi, the function returns us the value 0. So this will become 0 for all n, and sine of 0 is 0 also. So this is 0. That means we get in equal to in plus 2 for all n greater than equal to 1. So now we know, if we put n equal to 1, what we will get? I1 equal to I3. Similarly, n equal to 3 if we put, so it will become I3 equal to I of 5. So we can say that I1 equal to I3 equal to I5 equal to I7 equal to so on, and all those I corresponding to the all the odd numbers will become equal. So our given summation, that is I3 plus I5 plus I7 plus I9 plus so on up to 21 will becomes simply how many terms are there? So there are, the n is varying from 1 to 10. So basically here there are 10 terms. So 10 into, now this will become, all those integrals will become equal to I1, 10 times I1. Now we have to find and focus on this integral I1. Now see, we get in equal to 0 to pi integral sine of nx by sine of x into dx. Now if we put n equal to 1, then it becomes 0 to pi sine of x by sine x, that is 1. So this simply, the integration simply becomes pi. So our answer to this given question will be 10 times I1, so 10 pi. But now the question says that our answer will be equal to k pi. So the value of k will be 10. That is our answer. So this is the third question that we are going to discuss. The question says the integral 0 to 1 over 5 to the power greatest integer of 1 upon x dx is equal to what? So 4 options are given to us and we have to choose only one of them. Now if we are to evaluate this integral, so let me first draw your attention to this particular type of question. This question was somehow there was a slightly different number here, but the same format, the integration of same format was asked in JEE main 2022, and as we know, the questions of JEE main 2022 were much difficult than any other year. So if we can evaluate this integration for a general a or something like a general variable, derive a formula for a general variable, then we can remember that formula for our JEE main, or maybe we can remember the formula and solve those questions easier if this type of integration repeats further in JEE main exam. So let us evaluate this integral for some general a. A will be some constant. A will be greater than 1 and a is something positive integer. Okay, so let us evaluate this integration. Now we know in this integration x varies from 0 to 1. So 1 by x will vary from 1 to infinity. Now as we know the property of greatest integer, it breaks at every integer. So at every integer means 1 to 2 will be different function, then 2 to 3 will different function, and so on. This will continue up to infinity. So this integral will become, first let us change the limits, that is invert the limits, so that there will be a negative sign outside and the limits will change from 1 to 0. So this will be this value. Now minus sign will be outside and we have to break the function. So as we are going to 1 to 0, remember this 1 to 0 is for x, not for 1 by x. So we have to break this function as 1 to half, then again half to 1 by 3, then again 1 by 3 to 1 by 4, and so on. Because we know as x varies from 1 to half, 1 by x varies from 1 to 2. Similarly, as x varies from half to 1 by 3, 1 by x varies from 2 to 3. So the functions will be different. So this will be 1 over a to the power. So as 1 by x varies from 1 to 2, so greatest integer of 1 by x will be simply 1. This plus this integral. So as 1 by x varies from 2 to 3, the greatest integer will become 2. So it will be 1 over a square into dx plus this integral. So simply we can see the pattern here. So this will continue up to infinity. We don't need to write the infinite term, of course. So this will be minus outside 1 by a, as this is a constant, so half minus 1 plus 1 over a square, 1 by 3 minus half, plus 1 upon a cube, 1 by 4 minus 1 by 3, plus so on up to infinity. Now see, this is an infinite series. We need to solve this series to get our required answer. This. Now how do we solve this series? Now as we can see, the question displays the options as something in logarithmic term. So we have to create a logarithmic term here. But how can we create a logarithmic term here? We know the expression of log of 1 plus x and log of 1 minus x. So somehow we have to create these two expressions, two expansions here. So what is log of 1 plus x? It is equal to x minus x square by 2 plus x cube by 3 minus x to the power 4 plus so on. The signs will be like change alternatively, and then x to the power n by n. So this will continue up to infinity. Similarly, log of 1 minus x will be minus will be common. Inside the bracket will be x plus x square by 2 plus x cube by 3 plus x to the power 4 by 4 plus so on up to infinity. So let us create the value or try to evaluate the value of this expression log of 1 minus 1 by a by simply putting x equal to 1 by a. So minus 1 by a plus half of 1 by a whole square plus 1 by 3 into 1 by a whole cube plus so on up to infinity. And so we can see here this expression, and we have to create in our derived expression, which is, by the way, let me write it here. So it was so this expression, in this expression we have to create somehow this term. So in this expression, if we simplify this expression, so let me take the minus the negative terms together. So if we let us split the series into two parts, so 1 by a into half plus 1 by a square into 1 by 3 plus 1 by a cube into 1 by 4 plus this part is different, and then negative will come as common, and then this part 1 by a square into half, then simply up to infinity. Now see this expression, that is here will be a term as like this. So as we can see, this series is exactly same as this. You can compare and say that both are equal. So this part, so this is the minus sign is outside this second bracket, so negative sign outside, and then the first series, and then plus this part. This part is log of 1 minus 1 over a. Now we can see here that we can create the same term, same expression as this here if we can multiply this series by a and also divide simultaneously by a. So the expression does not change, but we can create the terms 1 by a whole square into half plus 1 by a whole cube into 1 by 3 and so on. So let me divide and multiply by a. So a will be outside, and then 1 by a square into half plus 1 by a cube into 1 by 3 and plus so on up to infinity. Now clearly see this term, this expression. This expression is corresponding to this expression. This expression is nearly similar to this expression, except this minus sign and this term. This term is missing here. So if we can perform a simple calculation, we can say that this remaining term will be equal to minus of log this term, and again minus, and then 1 over a. So this will be equal to a times minus log of 1 minus 1 by a minus 1 over a plus log of 1 minus 1 by a. So this will be equal to minus a log, so again a minus sign here like this, and then a into 1 by a will be 1 plus log 1 minus 1 by a. So if we simplify this expression, this will become a log 1 minus 1 by a plus 1 sorry, there will be a minus, and then minus log 1 minus 1 by a. So simply it will become 1 plus a minus 1 log of 1 minus 1 by a. So we have derived the expression for a general a. So you can remember this as a formula. So if we put a equal to 5, then we will get our required answer. So if we put a equal to 5, then it becomes 1 plus 5 minus 1, so 4 log 1 minus 1 over 5, so it is basically 4 over 5. So this is our required answer. So this is the fourth question that we are going to discuss. So here the question says these two integrals are given to us and we are to find the value of the sum of these two integrals. So as I can see, the integrand here and here are different, but there is some similarity between them because both contains a term of 1 plus t square and 1 plus t square. The idea is to get a similar integrand in both integrals. So let us work with the second function, second integral. So the second integral is this. So we can make the integrand same by substituting t equal to something 1 over let's say 1 upon p, because I can see here the upper limit is tan x and here the upper limit is cot x. So basically some t equal to 1 by p substitution will make our work easier. So substitute this. So dt equal to minus 1 over p square into dp. So as we can see here, so t varies from 1 by e to cot of x. So p varies from 1 over t. So p is basically 1 over t. So p varies from e to tan x. So the integral becomes e to tan x integration. Then dt will become minus dp by p square, and this will become 1 plus 1 over p square. So and again 1 by t is here. So 1 by t is basically p. So p will be above in the numerator. So this integral becomes, so p here will get cancelled, and if we simplify this, so becomes p square dp upon 1 plus p square and p here in the denominator and with a negative sign. So this becomes negative integral tan so integration e to tan x, then the integral becomes integral p dp over p square plus 1. So we know that the value of different integration does not depend upon the choice of variables. So we can replace p with t here. So this integral becomes negative of the integration e to tan x integral t dt over t square plus 1. So the negative sign is outside the integral. If we invert the limits, the negative sign will get cancelled. So this integral will become integration tan x to e, then inside the integration t dt over t square plus 1. This is the second integral. So we are to calculate the sum 1 by e to tan x integral t dt over 1 plus t square plus integral tan x to e t dt over 1 plus t square. Now see here, in the first integral the upper limit is tan x, and in the second integral the lower limit is tan x. So somehow we can add these two integrals, and as the integrand is same, we can directly add those two integrals if tan x belongs to the open interval 1 by e to e. So let us check. X belongs to pi by 6 to pi by 3, this open interval. Now as a result, tan x belongs to open interval 1 by root 3 to root 3. Now we know e is nearly equal to 2.718 and so on. This is an irrational number, and root 3 is nearly equal to 1.732. This is again an irrational number, so e is greater than root 3. Okay, so we can say 1 by e is less than 1 by root 3. As a result, we can see 1 by root 3 to root 3, this open interval is a subset of this open interval. So as tan x lies here, so we can say that tan x belongs to this open interval. So we can directly add these two integrals, as tan x is an interior point of this open interval 1 by e to e. We can directly add these two integrations as the integrand is same. So our required integral becomes 1 by e to e integral t dt over 1 plus t square. This becomes what? This is a simple integral which can be solved by dividing by 2 and multiplying by 2 here. So if we put 1 plus t square equal to something called u, then the numerator will be the derivative of this. So let us proceed with this substitution. Let u equal to 1 plus t square. So du will become 2t dt. So the limits of u will be switched to 1 plus e square and 1 plus 1 by e square. So this is half log u, and limit will be from 1 plus 1 by e square to 1 plus e square. So half log 1 plus e square divided by, now this if we put here, we can simplify this as e square plus 1 divided by e square. So e square will be in the numerator. So this get cancelled. So this is half log e square. This is half into 2 log e, and we know log e is 1. So the value asked is this. So this is our required answer. This is the fifth question that we are going to discuss. The question says, if this holds, then the value of I is equal to, and 4 options are given to us. So as per the question, LHS is equal to RHS. So let us simplify the LHS and then RHS so that we can find the value of I. So LHS is integration 0 to 2 root over 2x minus under root 2x minus x square times dx. So this can be split into 2 integrals like this. Now the first integral is quite simple. It can be solved as root 2 times the integration of root x is basically 2 by 3 x root x with limits from 0 to 2. So this will be how much? Root 2 times 2 by 3 times 2 root 2. So 8 over 3. And now we have to calculate this integral. So if we assume this function as y. So y is root over 2x minus x square, and y is positive because we know that anything if we take under root of a positive thing, then the under root, that is the output, is always positive. So y is always positive, or can be equal to 0 if x equal to 2 or x equal to 0 in this case. So here if we square both sides, then y square equal to 2x minus x square, or x square plus y square minus 2x equal to 0. So what is this equation? This equation corresponds to a circle which is centered at 1, 0 and has a radius 1. So let me draw it. This is our coordinate axis. This is the xy plane, and here this is the point 1, 0. This is the origin, and this is the point 2, 0. So y is basically, as y is greater than equal to 0, so y is the positive part of this circle, that is this region. So from 0 to 2, that is x equal to 0 and x equal to 2, we have to calculate the area of this part to evaluate this definite integration. So as the radius of this circle is 1, so this shaded area will be equal to pi times r square, that is 1 by 2, so pi by 2. So our evaluated integral equal to pi by 2 in this case. So the LHS is simplified. Then we have to focus on right hand side. So right hand side is basically the sum of these two integrations plus I. So the sum of those two integrations will be, let me write the integrals first. So now these integrations can be evaluated. Now the first integral can be evaluated easily, as this will be equal to 1 minus 1 over 6 and again 1 here. So it is basically 5 by 6, and here it can be evaluated as 2 times 1, so 2 minus 1 over 6, then 2 cube minus 1 cube, so 7. And then this integral you have to evaluate it. So what is this? So let us assume this function as x. So x is a function of y, then x is root under 1 minus y square, where x is positive or equal to 0. So if we square both sides, then x square plus y square equal to 1. This is a equation of a circle centered at origin. So here is the circle, here is the origin, and this is the point 1, 0. So we have to basically, so as x is 0, so x is greater than equal to 0, so we can remove this part because here x is negative. So the graph of x equal to root over 1 minus y square will look like this. So we have to evaluate the area of the part which is going from y equal to 0, so from here to y equal to 1 here. So the area required will be the area of this shaded region. So what is this? This will be equal to 1/4 of the area of the total circle. So it is pi r square divided by 4. So r is 1 again, so it will be equal to pi by 4. So this integral is equal to pi by 4. So let us simplify this. This is equal to 3 minus 8 over 6 minus pi by 4. So it is equal to 5 by 3 minus pi by 4. And also a plus I is there on the right hand side. So we have simplified the RHS and the LHS both. So as left hand side equal to right hand side, then we can say, so as left hand side is equal to right hand side, we can say I plus 5 over 3 minus pi by 4 is equal to 8 over 3 minus pi by 2. So we can find the value of I. It will be equal to 1 minus pi over 4. So we have to check the values of the integrals given in the options. So if we check one by one, the A option here, it says integration 0 to 1 minus root over 1 minus y square times dy. So as we can see here, this integral 0 to 1 integration dy will be simply 1 minus, and we already evaluated this part from 0 to 1 root over 1 minus y square dy. This is equal to pi by 4. So option 1, in option 1 the integral given equals the value of I. So this will be our answer. So A is the correct answer. So in the question 6 we are given a function fx equal to x square minus 2x plus 2, and we are to evaluate what? We are to calculate the area bounded by this function and its inverse. So we know the concept behind this question. The concept behind this question is, if we draw a function like this, let's say it is y equal to f of x, then the inverse of this function, that is y equal to f inverse x, will be the mirror image of this part about the line y equal to x. So the function y equal to f inverse of x, the inverse function of fx will be like this. The graph of that function will be like this. This is the concept. Now we can see this is the line y equal to x, and if we somehow get a function like this, we can get the inverse of this function like this. So there is a certain area bounded by these two functions. Now the area bounded by these two functions is, let's call it A. So this A is basically A1 plus A2, and we can see by symmetry A1 equal to A2 is equal to area bounded by y equal to fx and y equal to x. So our total area bounded by fx and f inverse x will be 2 times a1, that is 2 times 2 into the area bounded by y equal to fx and y equal to x. So let us proceed here. So if we put fx equal to x, then what we will get is x square minus 3x plus 2 equal to 0, that is x minus 2 into x minus 1 equal to 0, that is x equal to 1 and 2. So this function, particular function fx, cuts the line y equal to x at 2 points like this. So the total area bounded by that function fx and its inverse, let us call it f inverse x. The total area bounded by those will be 2 times. So the area will be 2 times the area bounded by fx and x between x equal to 1 and x equal to 2. So this will be 2 times integration of 1 to 2 fx minus x times dx. This will be equal to, and we also have to put a modulus sign here because we are talking about area, which is always positive. So this area, net area, will be equal to what? This will be equal to x square minus 3x plus 2 into dx, and then we simply integrate it. So x square will be 1 over 3 and 2 cube minus 1 cube will be 7 minus 3 times half as coming from the integration of x square. So 2 square minus 1, so this is basically how much? 4 minus 1, so 3, plus 2 times 2 minus 1, so 1, 2 times, there is a modulus sign here, so 7 by 3 minus 9 by 2 plus 2, 2 times, so if we calculate the LCM here, 14, it is basically 2 by 6 into, this is minus 1, but if we take the modulus sign it becomes plus 1, so 1 over 3. So in the question we are asked the value of 3a, so 3a is basically equal to 1, so this is our answer. So this is the 7th question that we are going to discuss. So in this question we are given equation involving some integration of some function fx. So we are basically asked to determine the value of f square 1. Now for this value we have to find the value of fx or the expression for fx or f square x. So as this equation is given, we know by the property of definite integration that for some a greater than 0, if we have something positive here, that is we have some positive integrand over this interval 0 to a, let's say as this is phi x, and phi x is positive for x belongs to 0 to a, open 0 to a. So if this is 0, then it implies that phi of x should be 0. So this is the concept behind this question. So we have to express this LHS as something integral, and we have to have the integrand as some positive function inside this interval, i.e. open 0 to 1. So let us try to make this as an integral. So by observing this integrand, we can observe that it is nothing but the square of f square x. Similarly, this term we can write as minus 2 into f square x into 4. So basically something like a square completion is coming, like striking my mind here. So I am trying to complete this square. So for completing this square I have to add 4 square, so it's basically 16 here in the integrand. So let's try to make a whole square term here. So it will be f to the power 4x minus 8x square f square x plus here 16. So the dx will be outside, and as we added integral 0 to 1 16 dx, we have to subtract this. So basically we have to like sorry, this my mistake, sorry, this would be 16x to the power 4 because there is also a x square here involved. So this will be 4 times x square and whole square of it, so it would be whole square of 4x square means 16x to the power 4. So basically we added 16x to the power 4 dx and integration of that from 0 to 1. So here also 16x to the power 4 dx and integration of that from 0 to 1, and the term here as it is. So basically we are getting this expression. So inside this integral, the integral is simply the square of this term. And here if we evaluate this integral, this is 16 by 5 x to the power 5 with limits from 0 to 1. That means it is equal to 16 by 5 with a negative sign, and this is positive 16 over 5, so this will cancel each other. So the both will cancel each other, equal to 0. So basically we are left with the expression integration 0 to 1, then f square x minus 4x square and whole square of that, and also the integral of that from 0 to 1 is equal to 0. So we can match this expression with this expression here, like this is our phi x, and this is always positive for this interval 0 to 1. So we can say that f square x minus 4x square is equal to 0. So f square x is equal to 4x square. So in the question we are asked the value of f square 1. So putting x equal to 1, f square 1 is equal to 4. That is our answer to this question. So this is the 8th question we are going to discuss. The question says let f be a differentiable function satisfying this integral equation. Then the value of integration of minus 2 to 2 f dash x plus fx dx is equal to 4 options again. So basically we have to solve this integral equation to find fx. This is like the limit here in the integration is variable, so we have to find the concept here. The concept is Leibnitz rule for differentiation under integral sign. So what does this rule says? That if we have some function here of x in the limit, and also here gx as the upper limit, and then we have some function here, and basically this is our an integral which is a function of x, and the limits of this integration is also a function of x. So then we can determine this I dash x, that is derivative of this integration, which is equal to according to Leibniz rule, we put the upper limit here inside this function phi t, and we multiply it with g dash x, that is derivative of upper limit, minus similarly we put fx here and also multiply it with the derivative of this lower limit. So this is our Leibniz rule. So this is the concept that we have to apply here. But there is a constraint in this rule. We can only apply this rule whenever the integrand is purely a function of any other variable. That is, no x or the variable on which the limits of this integration depends does not have any contribution to this integrand. But here in the given equation we have this contribution of x, so we have to somehow remove this contribution of x here. So what can we do? We can simply apply the King's property of definite integration here. So according to the King's property, integral fx dx from a to b is same as integral a to b f of a plus b minus x into dx. So we have to apply this. So this implies in the given equation, if we substitute p with x minus p, so let us first separate these parts. So in the given equation we basically split all those terms x minus p plus 1 into fp as x of x into fp dp, and this x can be taken outside. So let me write it here, integral 0 to x fp dp, and then integral 0 to x p f of p dp, and then 0 to x integral f of p dp is equal to x to the power 4 plus x square. So basically x plus 1 integral 0 to x f of p dp minus 0 to x p f of p dp is equal to x to the power 4 plus x square. So now we apply the Leibniz rule here. Now this is a product function of x, so this is ux and this is vx. So we apply the product rule of differentiation here. So the differentiation of first, that means 1, and second function plus this derivative of this times this function. So x plus 1 into, as from the Leibniz rule we can say the derivative of this function will be fx, minus derivative of this function will be x f of x is equal to x to the power 4 plus x square, and derivative of this whole RHS, that is 4x cube plus 2x. So here we can simplify 0 to x f of p dp plus, see here x fx and minus x fs will get cancelled, and so we are left with only fx equal to 4x cube plus 2x. So now we can see, if we differentiate this whole expression again with respect to x, we get, by applying Leibniz rule here, fx plus differentiating this will give f dash x is equal to 12x square plus 2. Now this is the required function. So in the question we are required to find the value of integral minus 2 to 2 f of x plus f dash x into dx. That will be equal to 12 times, that will be equal to 12 times minus 2 to 2, and then this integration will be equal to x square plus x square dx plus integral 2 dx from minus 2 to 2. So 12 over 3 x cube from 2 to minus 2 plus 2 times x, 2 into minus from minus 2 to 2. Then this will be 4 times 8 minus of minus 8, so 16, plus this will be 2 times 2 minus of minus 2, so 4. So this is 64 plus 8, that is 72. That is the answer to our question. So this is the 9th question that we are going to discuss. The question says that f of t is a integral dependent on t where the integrand is this function. So in the question it asks us to find the value of f1 plus f dash of 1 is, we have to find this value. So this is the integral given to us, and this integral is a function of t. So we can apply Leibnitz rule here. So we can differentiate both sides with respect to t. So f dash of t will become, like if we apply Leibniz rule here, it becomes e to the power t square into t to the power 5 over t to the power 4 plus 2t square plus 2 and the whole square in the denominator. So if we put t equal to 1, then f dash 1 comes as e to the power 1, so e into 1 to the power 5, so 1, and here in the denominator 1 plus 2 and whole square of that, so this is basically 25, so it is e over 25. Now we have to find the value of f1. So for that we need to find the function f of x. So how can we find the function f of x? So f of t we have to find, as the integral is a function of t, and we have to integrate the given function. So let me write the integral here. Now here we have to solve this integral by substituting x square equal to some variable, that is let's say p. So 2x dx will become dp. So we can write this integral as integration 0 to t e to the power x square into x square and whole square of that into x dx over x square whole square plus 2 times x square plus 2 and the whole square of the denominator. So if we substitute these values, it becomes half integration e to the power t into t square into it will be e to the power p and then p square into dp divided by p square plus 2p plus 2 and whole square. and the limit will be from 0 to t square. The limits are changed to that of p. So now we have to solve this integration. How can we solve it? So integration 0 to t square, here e to the power t, let us take it outside the fractional part. So here we can write p square as p square plus 2p plus 2 minus, we have to subtract this part as we are adding this to this. So minus 2p plus 2 over p square plus 2p plus 2 and whole square. So then we proceed. E to the power p into, inside the bracket there will be 1 p square plus 2p plus 2 will get cancelled with here. So 1 over p square plus 2p plus 2 minus this term 2p plus 2 over p square plus 2p plus 2 whole square into dp. Now let us put phi of p equal to u, and phi of p is what? This term 1 over p square plus 2p plus 2. So then let us put this function as some function of p. So it is basically phi p. Then derivative of this function with respect to p, that is phi dash p, will become minus of p square plus 2p plus 2, that whole square, and the derivative inside this function, so 2p plus 2. Now see here, if we are assuming this part as phi p, then this whole part is basically phi dash of p. So our concept in this question is that integration of e to the power x times some function of x plus derivative of that function, and integral of all this will be equal to e to the power fx. You can prove it by using integration by parts. So here also a plus c, as this is a indefinite integration, so we can use this fact here. So from the last step we get half integration 0 to t square, then e to the power p times phi p plus phi dash of p, where phi p is a function of x and phi p is basically 1 over p square plus 2p plus 2. So this will be how much? Half into integration of this will be this, so integral of this will be e to the power p phi of p with limits from 0 to t square. So and phi p is this, so it will be half of e to the power t square phi of t square minus e to the power 0 is 1, so phi of 0. Now using this 2 we can conclude that half this will be half of e to the power t square into phi of t square, means 1 over t to the power 4 plus 2t square plus 2, and minus phi of 0 will be half. So it will be equal to half e to the power t square over t to the power 4 plus 2t square plus 2 minus 1 by 4. This is our function of t. So if we put t equal to 1 here, then we get the value of f1, which is half of e to the power 1. So e over t equal to 1, if we put that, it will become 1 plus 2 plus 2, so 5 minus 1 over 4. So e upon 10 minus 1 by 4. So we are asked to find the value of f1 plus f dash of 1. This will become e by 25 plus e by 10 minus 1 by 4, which is equal to, you can calculate it, it will be equal to 7e by 50 minus 1 over 4. This is our answer. This is the 10th question that we are going to discuss. So this is the last question of this problem sheet. So here it says that fx is given as this function, and we are to find the value of this integral. So now here in this integration we can see that the sum of the limits of this integral is 1. So if we apply King's property here, that is integral a to b fx dx is exactly equal to integral of f of a plus b minus x dx from a to b. This is the King's property of definite integration. So this becomes f of 1 minus x. Now there must be some relation between f of x and f of 1 minus x. So let us try to observe that relation between f of x and f of 1 minus x. So let us put 1 minus x instead of x here. So it becomes 1 minus x whole cube minus 3 by 2, 1 minus x whole square plus 1 minus x plus 1 over 4. This becomes 1 minus 3x plus 3x square minus x cube minus 3 by 2 into, inside the bracket, 1 minus 2x plus x square, and then plus 1 minus x plus 1 over 4. This becomes 1 minus 3x plus 3x square minus x cube minus 3 by 2 plus 3x minus 3 by 2x square plus 1 minus x plus 1 over 4. So the plus 3x and minus 3x will get cancelled, and also here 2, the constant term will be 2 minus 3 by 2 plus 1 by 4. So it is half plus 1 by 4, and then minus x cube plus, so it is basically plus 3x square minus 3 by 2x square, so plus 3 by 2x square, and then minus x. Now as we can see, this part definitely gives us the feeling of our fx, which is the negative of this term, negative of fx, and plus 1 over 4. So this term is basically negative of fx plus 1 over 4. So we can write it as half plus 1 by 4 plus 1 by 4 minus fx, and so it simply becomes, this will sum up to be 1 and then minus fx. So we can see that f of 1 minus x will become equal to 1 minus fx. So this is the property, special property of this given function. So we can use this relation here in this integration. So the integration 1 by 4 to 3 by 4 f of 1 minus x dx is simply 1 by 4 to 3 by 4 integration f of 1 minus f of x dx. Let us call this integration as I. Okay, and as this integration is same as this integration, so let us also call this as I. So if we add the two i's, so basically it gives us 2i is equal to 1 over 4 to 3 over 4 integration f of fx times dx plus again integral 1 by 4 to 3 by 4 f of 1 minus f of x into dx. Now we previously derived this f of 1 minus x equal to 1 minus fx. So we can say f of 1 minus x plus f of x is 1. So we can add these two integrals because the limits are same. F of 1 minus f of x plus f of x times dx. So as here we can see this fx inside this f as some variable as a t. So f of 1 minus t plus f of, again this will be t. So f of 1 minus t plus f of t is always equal to 1. So we can substitute this as 1 times dx. So this is a simple integral. So this will be equal to 3 by 4 minus 1 by 4 is 2 over 4. That is 1 over 2. So the value of I, which is the required value of this definite integration f of fx dx from 1 by 4 to 3 by 4 is basically half divided by 2. So 0.25. This is our answer.